back in section 5.1, we talked about what a system of equations is, or what an answer for a system is. And then in section 5.2, we talked about graphing lines. Today we're going to put those two things together. We're going to talk about solving systems of equations by graphing. All right, so I'm going to give you a system of equations. The system of equations is 6x plus 3y equals 12. So there's one equation. And y equals negative 2. No, let's go negative 3x. And then I got to make this work out nicely. Plus 4, I think is the right number that I want. Okay, so well, what do we mean when we say solve systems by graphing? What do you think we're going to do?
I think if we solve equations for y and then we put them on a graph and then we see where they go to the set and the solution.
You're exactly correct. What we're going to do is we're going to graph both of those lines. And the answer to the system will be where do those two lines cross. The only thing I disagree with you just a teeny tiny little bit is you said I need to take both of those equations and solve them for y. You can do that. I don't think that's in your best interest, and I'll show you what I mean in just a minute. So first, let's graph the second line, because the second line is easier. How do you graph y equals negative 3x plus 4? I start at 0, 4, and I make sure I label my axis here, 0, 4. And then I go down 3 to the right one. And then I could do it again, go down 3 to the right one. I'm going to label one more of these points. This one has the point 1, 1. All right, now the first line. Say that again. Okay, so what you did is you took that line and you got y all by itself. Yes. And that's the way an awful lot of students like to do it. And there's absolutely nothing wrong with it. In fact, in just a minute, we're going to see how to do these on our calculator, and we'll have to do that with our calculator. Me personally, if I was graphing that line, I would not get y all by itself. Here's what I would do. I would build myself a little chart. And I'm going to pick my favorite number in the whole wide world. What's my favorite number in the whole wide world? No. 0 is my favorite number in the whole wide world. Why do I like 0 so much? That's what I'm worth? Is that what you said? No. I like the 0 because it's really, really, really easy to plug in. What's that? It does make things easier when you plug it in. So if I plug in 0 for x, what's 6 times 0? So this part would disappear, wouldn't it? And I would have 3y equals 12. And you can do that in your head, can't you? Y is 4. And then I'm going to take my favorite number in the whole wide world, which is still 0. But this time I'm going to plug it in for the y number, which is a little weird. You don't usually plug stuff in for y, but there's no reason why you can't. If I plug 0 in for y, what's 3 times 0? So that part disappears, and I'm left with 6x equals 12. X equals 2. So I like doing it that way because I can do all the arithmetic in my head, and it's very simple arithmetic. Now, unfortunately, sometimes when you try to do it that way, the answers come out to be fractions, and then I don't like it so much, and then I don't do it that way, and then I get y all by itself. Is it wrong to get y all by itself and do it that way every single time? Absolutely not. Of course you can get y all by itself and do it that way if you want. And I find that that's what most students are comfortable with. If you like doing it that way and that works for you, then do it that way. Okay? All right, so I have 0, 4, which is right there, and I have 2, 0, which is right there. These lines are almost parallel, but not quite. They were pretty close. Do those two lines cross? Yes. Where do they cross? They happen to cross at a real nice point, don't they? They happen to cross at 0, 4. So there's our answer. Those two lines cross at the point 0, 4. That is the solution to that system. And you could very easily check that when I plug in x equals 0 and y equals 4, I get 12. When I plug x equals 0, I get y equals 4. That's the right answer. All right, let's try another one. Somebody make up an equation for me. Give me a nice line. What's your favorite line? Y equals 5. All right.
That's a pretty nice line.
That is a nice line. Okay. I asked for it. I guess I have to accept it. Not what I wanted, but I'll take it. Y equals 5. Give me another line which is not horizontal. X equals 4. Yeah, I figured somebody was going to be that smart too. X equals 4. You think the intersection is 4-5? 4, 4. Yeah, I think it has to be, doesn't it? All right, well, this isn't a bad thing to review. Y equals 5. What does y equal 5 look like? That's a horizontal line. Although that usually bothers people because y goes up and down, but y equals 5 is a horizontal line. Because y always stays the same. Y is always the number 5. It doesn't matter what x is. You're absolutely right. So y equals 5 looks like this. Goes through the point 0, 5. And x equals 4 is what kind of line? It's a vertical line. It looks like this. X equals 4, so it goes through the point 4, 0. And you already told me the answer. The answer is 4, 5. No doubt about it. That's clearly where those two lines cross. All right. So now let me rephrase my question. Somebody give me a line which is neither horizontal nor vertical. Y equals 3x minus 2. That's a good line. Somebody else give me another line which is neither horizontal nor vertical. Y equals x plus 4. All right, excellent choices. I wish to see where those two lines cross, which is another way of saying I want to solve the system of equations. All right, how would you draw the first line? Y equals 3x minus 2. Intercept is 0, -2. And the slope is up 3 over 1. Good. 1, 2, 3, 1. 1, 2, 3, 1. So this happens to be the point 1, 1. And there's the answer. All right, how about the second line? Intercept is 0, 4, which is right there. And the slope is 1, 1 over 1, 1 over 1. Looks like so. That's 1, 5. Do those two lines cross? Yes. Where do they cross? Looks like what? 3, 7? Are we absolutely sure that 3, 7 is the right answer? Yes. Why? Let's plug it into both and check and make sure. If I plug 3 in, 3 times 3 is 9 minus 2 is 7. Plug 3 in here. 3 plus 4 is 7. Not 9. 7. All right. So what happened was not supposed to happen. And what I mean by that is usually when you make up two lines just kind of at random like that, they're not going to cross at a pretty point like 3, 7. They're usually going to cross at some fraction or some decimal. So you guys were really good pickers today. You happened to pick numbers, gave me equations where the lines just happened to cross right at a nice spot. Totally was not planned. That's why I say you guys are good pickers. This is very lucky. That's okay. All right, so let's try again. Let's make up 2 more equations and see if we can get some ugly answers. Y equals, give me an equation. 5, 6x plus 2. All right, I like that. Throwing some fractions into our slope. That's a good idea. Y equals, how about negative 1/3? We haven't used a negative slope yet. Negative 1/3 x plus 9. All right, very good. Before I even start to graph, do I know if those 2 lines are going to cross or not? Yes, you know those 2 lines will cross at some point. How do you know that for sure? One has a positive slope, one has a negative slope, so they have to cross. More importantly, their slopes are not equal. So even this one back here, where this one had slope of 3, and this one had slope of 1, I knew they had to cross because they had different slopes. So we know there is an answer. We're absolutely sure of that. All right, the first equation. I have the point 0, 2. And then I go up 5. That puts me at a height of 7. And to the right 6. 2, 3, 4, 5, 6. So right there's the point 6, 7. All right, so there's line number 1. Line number 2 had an intercept at 9. Right there. And then it goes down 1 and over 3. So that's 3, 8. All right, so these cross. Do they cross at a nice point? You guys are amazing. They just so happen to cross at 6, 7, don't they? This is funny. I've never ever had that happen before. That we make up 2 lines in a row like that by random and we get 2 nice answers. Because if I plug in 6, 5 over 6 times 6, and 6 is reduced out, I'm left with 5. 5 plus 2 is 7. And when I plug 6 in here, negative 1/3 times 6 is negative 2. Negative 2 plus 9 is 7. The answer happens to be 6, 7. We're going to try again. We're going to get this right eventually. Get a dartboard. Throw things at a dartboard. All right. I can't make you guys make it up. You guys are too good. I'll have to make it up myself. Y equals negative 1/2 x plus 2. Y equals x plus 3. All right. So we're getting pretty good at graphing these lines, at least. We've gotten lots of practice. This one has an intercept at 2. It goes down 1 over 2. Down 1 over 2. So it goes through 4, 0, 0, 2. Play connect the dots. This other line goes through 0, 3, green. And then it goes up 1 over 1. Up 1 over 1. So we have 0, 3 and 2, 5. All right, now do those 2 lines look like they cross at a nice spot? No, they don't. Can we approximate where they cross? How about negative 0.5? It looks like maybe like it's like negative 0.5 and 2.3. That's a good approximation. What we're going to do in cases like this is we're going to use a calculator. Oh, my battery's over. All right, so we're going to go to y equals. And we're going to graph negative 1/2 x plus 2. And then we're going to graph x plus 3. So we're going to type those in. Type 1 is y1 and yn is y2. Draw graph. To draw a graph, I always like to go zoom 6 to make sure I have the regular old window there. So there's the two lines. Looks like the picture I drew. That's pretty good. I went zoom, and I like to do number 6. What zoom 6 does is it makes the x's go from negative 10 to positive 10, and it makes the y's go from negative 10 to positive 10. So a lot of people just hit the graph button. I always like to go zoom 6 because then I always know what my window is. Because maybe I was doing something before and I had to change my window and I had some weird picture. It does. When you press zoom 6, it resets your window. That's why I always like to go zoom 6 instead of hitting graph. All right. Anybody know how to use the calculator to find where those two lines cross? Second trace, which puts you into the calculate menu. You go down to number 5, which is intersect. Intersect is a fancy way of saying where things cross. Put in it. It asks me, is this the first curve? And notice up here it has y equals negative 1/2 x plus 2. Is that our first equation? Yes, I hit enter. Then it says, is this the second curve? y2 equals x plus 3. Yes, I hit enter. Then it says, make a guess. I can just hit enter. Or if I want, I can use the arrows to get over a little closer. Doesn't really matter. I hit enter, and it will give me the answer. And it will give me a very, very accurate answer. Many, many decimal places. Yeah, and you were pretty close. Negative 0.5, well, it's negative 0.6666. What's negative 0.66666 repeating like that? That one happens to be negative 2/3. And how about the other one, 2.33333? 2 1/3. So the actual correct answer is negative 2/3, 2 1/3. Now again, I will warn you, the answers don't generally even come out that nicely. They won't generally come out as decimals like that, where you might happen to recognize the fractions. So when you do your homework in my lab, quite often the directions are going to be use your calculator to solve, round your answers to 2 decimal places, or something along those lines. So if they want you to give decimals, they're usually very good about telling you how far to round off. So look for that. Questions on that? All right, so I'm starting down in the middle here. It says, 2 different gasoline oil mixtures are available. One contains 20% oil and the other 50% oil. How much of each should be mixed together to obtain 10 gallons of fuel that is 40% oil? And then it gives us some variables. Let X be the amount used in the 20% oil mixture. Let Y equal the amount in the 50% oil mixture. And then it tells us one equation has to be X plus Y equals 10. Why does one equation have to be X plus Y equals 10? So I'm starting with some gallons here. I'm starting with some more gallons there. And I'm dumping them together. And I end up with 10 gallons. So the amount of liquid here plus the amount of liquid there, when I get all done, I'm going to have 10 gallons. So there's our first equation. Second equation, we have 0.20x plus 0.50y equals 0.40 times 10. What does 0.20x represent? It's 20% oil. And they even say that down below, and I kind of do it in the picture. So this has X gallons in it altogether. 20% of that is oil, so they tried to shade in 20% for us there. This one is 50% oil, so 0.5 times however much is in there, and 0.4 times 10, that's how much oil is in our final mixture. So our second equation is 0.20x plus 0.50y equals 0.4. I guess I could write that as I wanted. No, that would just be 4. 0.40 times 10 is 4. All right, flipping the page here. We now have a system of equations. Our first equation was x plus y equals 10. And our second equation was 0.2x plus 0.5y equals 4. And they did a really clever thing. They took this equation and they multiplied everything by 10. Multiplying everything by 10 moves the decimal place over, gets rid of all those ugly little decimals. And that's a really good idea. If you have an equation that has decimals in it, multiply by 10 or 100 or 1,000 or whatever you need to get rid of the decimals so that you have integers. Makes it a lot easier. 2x plus 5y equals 40. All right, now it says, graph both of those lines together on the grid below. Then determine the approximate point of intersection. This is the solution. Why do you think only the first quadrant is included? Well, let's answer that question first. Why are we only using the first quadrant? Without it, we would have model breakdown. What does X stand for again? The amount of liquid. Can we have negative 2 gallons of liquid? No. And what does Y stand for? The amount of liquid in the other oil drum that we have. Again, can we have minus 2 gallons of a different liquid? No. Question. That's exactly right. The only relevant answers are X and Y both have to be positive because X and Y both stand for amount of oil or amount of liquid in the drum. So we only really need the first quadrant. All right. So it says to graph them by hand, so we will, and then we'll use our calculator. How would you graph X plus Y equals 10? Solve for Y, okay. If I solve for Y, Y is negative X plus 10. All right, so I'm going to start at 0, 10. And then go down 1 and over 1 and down 1 and over 1. That's good, except it puts the dots close, and then it's kind of hard to draw straight when the dots are close like that. So I think what I'm going to do instead is I'm going to pick a different number for X and plug it in. I'm going to plug in X equals 10. What happens when I plug in 10? Y is 0. So that just kind of spreads it out a little bit. Makes it easier to put my ruler on there and connect the dots. Turns out I lied. I didn't bring a ruler. But I have a calculator case. Calculator case works pretty well for drawing lines. And when you're doing these, it is pretty important to have a grid that's accurate. And if you have a ruler, it really helps. The more accurate your line is, the better answer you're going to get when you're all done. All right, how about our second equation? 2x plus 5y equals 40. Want to solve for y again? Okay. Again, I wouldn't. I would draw a little chart and plug 0 in. But I'll solve for y this time. I'll play along. 5y equals minus 2x plus 40. And then divide things by 5. Make sure you do it everywhere. So y equals negative 2/5 x plus 8. All right, so I have 0, 8. Oh, this time because I have fractions, I don't want to plug a number in, so this time I will just use the slope. Seems easier. Down 2, 2 over 5. 1, 2, 3, 4, 5. Play a nice game of connect the dots. There we go. Alright, so once again, where do those two lines cross? Looks like it's about 3 1/4 for x. And how about y? $8.5? I think that's a little high. Because this is 5, 6, 7. It's somewhere between 6 and 7. It looks like it's more than halfway up to me on my graph. I'm going to go with 6.75. or 6 3/4. Again, that is an approximation. When you graph by hand, sometimes that's the best you can do, is come up with an approximation. All right, so now try it on your calculator. Type those two equations into your calculator. Find where they intersect. Tell me what you get for an answer. I got the same answer. From the calculator, I got 3 1/3, 6 2/3. So how good was our approximation? Not bad. Not bad. Of course, it's nice to have the calculator. The calculator gives you a very accurate answer. Questions on that? A space shuttle and a damaged satellite are 384 miles apart. The shuttle travels at 836 miles per hour and the satellite at 682 miles per hour in the same direction. How long will it take for the shuttle to catch up with the satellite, and what is the distance? T is the time it takes for the shuttle to catch up to the satellite. D is the distance traveled by the shuttle to catch up with the satellite. The distance D can be represented in two different ways. Using the formula D equals RT, distance equals rate times time, express the distance D with two different expressions involving time. All right, so let's start with the satellite. Satellite starts right here. And it goes to there. So how far does that satellite go? Don't know, but write a formula for it. Distance is, what's the rate of the satellite? 682, so that's the slope. Distance equals rate times time. So distance is 682 times t. So there's the distance of the satellite. And over here we're going to have the distance of the shuttle. All right, how far does the shuttle go? What's that? However far it needs to catch up with the satellite, okay. What's that? All right, so its distance is its speed, so it's the speed of the shuttle, 836 times the time plus, very good, plus, why do I have a plus 384 for the shuttle? It started 384 miles behind, didn't it? So this distance is the distance that the shuttle goes, but the shuttle has to go an additional 384 miles in order to catch up to that satellite. Okay. Now, enter these two equations into your graphing calculator. Use y for d and x for t. Graph the lines using the following window settings. Y equals 682x, x I said, whatever I hit, 682x, and then this one was 836x plus 384. Now it's telling me use this specific window. Why is it telling me to use that window? Those numbers are big, so we need to change. This answer isn't going to fit between 0 and 10, is it? So that's kind of nice that it tells us change the window. So I'm going to go to window. X min is 0. X max is 5. X scale is 1. Y min is 0. X max is 4,000. Y scale is 1,000. Y scale equals 1,000. What does that do? Anybody know? It sets the tick marks. That's right. So one tick is now going to be 1,000. So it's going to be 1,000, 2,000, 3,000, 4,000. Exactly correct. It goes all the way up to 4,000. So the ticks are going to be 1,000, 2,000, 3,000, 4,000. Right. Yeah, something's definitely not right, is it? Why is something definitely not right? I can't see the intersection. Even worse than that, looking at that picture, where is the intersection going to happen? It does happen. Unfortunately, it happens down over here in the third quadrant. I want to say third also. And that doesn't make sense. How come that doesn't make sense? And I can't have negative time either. All right, so that doesn't make sense. Well, but that's not what they said. They said the shuttle was behind the satellite, and it's trying to catch up.
Is the shuttle going around the planet using the planet's gravity?
Well, in reality, yes, the shuttle and the satellite are both going in a orbit. But they're saying, for this situation, let's assume things are moving in a straight line. And that does make some sense because an orbit around the Earth is really, really large. If you look at just a small chunk of it, it really does look like you're flying in a line. And, you know, as far as the shuttle goes, only going 384 miles is really pretty short. So it looks very close like a line. All right, any ideas where our mistake is? It's something in the formulas. The scaling is fine. It's got to be the formulas, because looking at these formulas, our answer is down here in the third quadrant, and that can't possibly be right. It has to be in quadrant 1, because time has to be positive, and distance has to be positive. We're very close. We're off by a minus sign. A minus sign. What we did when we drew our picture is we considered this starting distance right here. We said if the satellite is 682t, then this is 0 right here. Our intercept is 0. The shuttle is therefore not plus 384 feet ahead, it's minus 384 feet behind. So our mistake was right there. We really should have had a minus. But I like that we came up with the wrong answer, and we knew we had the wrong answer, and we had to think about what we did wrong. I led us astray, that's right. There we go. Now we can see that the shuttle is going to catch up to the satellite and pull its big arm out and grab it as it goes by. And of course, we can find the answer. And our answer is x, which is pretending to be t. So t is about, I'm going to call it 2.5. So it's going to take about 2.5 hours. And they're going to fly about 1701 miles. That's not y, that's b. Questions on that? All right, the last thing in this section is very, very quick and very, very brief. Of course, it's possible that we might have two parallel lines. So we might have two equations. The lines might turn out to be parallel. So what's the answer to the system? There isn't one. So not all systems have answers. The lines might be parallel. The other possible thing that can happen is you might have two equations, but it turns out the two equations are really exactly the same. They're just written differently. in which case there are an infinite number of correct answers. It's every spot on the line because the two lines are exactly the same. So watch out for that. Sometimes you might be doing your homework and you might draw two lines and the two lines will be parallel. That's okay. You'll just say there's no solution. Or you might have two different equations and you'll do some work and you'll graph them and one falls right on top of the other. Then it really means you really had the same equation, and that's okay too back in.